Welcome back. We are working on Module 6. We're continuing to talk about collecting data, but this time we're going to be talking about conducting an experiment. So for question 1, the type of study that is the focus of this module is experiments. Why do we perform experiments? We left off Module 5 asking, can we infer cause and effect from an observation? The answer was no. The primary goal of an experiment is to be able to provide evidence for a cause and effect relationship between two variables. How do we do this? What does an experiment do? Well, an experiment is one in which you intentionally manipulate the explanatory variable. The thing that we want to know causes an effect on something else. So we do what's called imposing treatments. So in an attempt to determine if there's cause and effect, we intentionally manipulate the explanatory variable. I'm putting cause and effect in quotes because remember, the whole goal of an experiment is trying to determine if there is cause and effect. Sometimes we have what's called confounding variables. We define this in Module 4, where confounding variable is one whose effects cannot be separated from the explanatory variable to determine if it caused the response variable to change. So remember, I gave the example of the tomato plants and the water and the fertilizer. How do we try and control the effects of that confounding variable? Well, I can control and I can create a plot that has light and a plot that doesn't have light. And in those plots, give both fertilizer and not fertilizer. That's called direct control. You are creating some sort of design in your experiment where you're providing the two different situations. So if I think that gender might impact blood pressure medicine, I want to create a category for males and not males. I want to control for that. Another way is to do random assignment. I randomly assign people to their groups to help try and control confounding variables. Now, remember, the goal of direct control is to stabilize the impact of confounding variables across the treatments, try to level it out and even the playing field. We use random assignment to try and create similar groups. And that way, any of the differences that we see can be attributed to the response variable that due to the treatments that are given. So to create groups that are similar, and that way the differences that we see in the response variable, I should have added that in there, can be attributed to the differences in the treatments. And when I say treatments, if I'm talking about fertilizer, I would have fertilizer and not fertilizer. Those would be the treatments. How do you choose between direct control and random assignment? Well, when there are confounding variables that can't be controlled or are difficult to identify in advance, we're going to use random assignment. But if we can identify any confounding variables before we create the experiment, we want to go ahead and use direct control. The next question that we're asked to talk about is an example from OLI. Remember, there are a lot of things in the OLI that you need to be working through that are not necessarily addressed or talked about in these videos. There are the research questions, the learn by doings, the did I get this? Those are not necessarily all going to be covered here. And some of the material that's covered here is not going to be covered in OLI. So you want to be making sure that you're doing both. So in this question that was on page 23, a high school student was asked to study the effects of music on rats' ability to run a maze. And so he trained 71 rats to run a maze, and he divided the rats into 3 groups. And for the next month, one group listened to heavy metal music, a second listened to Mozart, and then the third never heard any music. So in that group was considered the control group. And they ran the same maze 3 times a week for a month. The response variable is the time it took them to complete the maze. By the end of the month, the Mozart group was running faster. The dot plots shown give the run times for the first week and the last week of the experiment. And 1 dot is 1 rat. The value is the rat's average runtime for the week. And each rat ran the race 3 times a week. So the blue line is the average for each treatment group. And remember that mean means average. So he claims that he randomly assigned the rats to the treatments. So here are the pictures. This is the anthrax group. And this is the Mozart group. And this is the control group. And this is the first week. This is the 4th week. And you might look at the second graph and think, well, anthrax did way better because they're way higher. But this is time. That means it took longer. And so the group that took the least amount of time was the Mozart group. And then those blue lines that they have shown, I'll show you here with my little pink, that's the average. So the Mozart group had the smallest average. It took them the smallest amount of time on average to complete the maze, but the anthrax group the most. And they want to know, it says that he claims he randomly assigned the rats. And does this support that? Well, if you look at the first week, all of the rats, all of the groups look kind of the same. It doesn't look like one group is ahead of the pack. So yeah, since each group in week 1 had similar overall mean run times here, they're kind of similar together. It's not as spread out as you see in week 4. It looks like, yeah, he sure did randomize the rats. The control group is the group that receives no treatment. They didn't receive any type of music. When you're conducting an experiment, you want to have some sort of control group. You want to either compare to somebody that doesn't receive a treatment, or let's say if you're trying to figure out if one blood pressure medicine is better than an old blood pressure medicine, you want to have somebody having the old blood pressure medicine. And we talked about a placebo in module 4, but the placebo effect is when people respond in a positive way to a treatment that doesn't have any active ingredients. In order to create or conduct a well-designed experiment, you want to include randomization, direct control, and replication. Randomization is when you're randomly assigning to the treatments. Direct control is when you're trying to control for any confounding variables. And replication means you're doing it more than once. You have more than one rat run the maze. You're doing it with a lot of rats so that the one rat, it can't just be that this one was a genius rat that ran faster. You want to do replication. And then filling in the blanks. Random selection and sampling can control bias. So this is sampling, not experimentation. This control bias. but random assignment and experiments can control the effects of confounding variables. A lot of definitions that you see here, you'll be asked about what's the explanatory variable, what's the response variable, what might be a confounding variable in this study. Would it be necessary for you to blind or to single blind or double blind? What might be 3 ways in which you would create a well-designed experiment? Is this a good experiment? Those types of questions. When we get into the next section, module 7, we're going to use StatCrunch to start calculating. We're going to start talking about shapes of distributions and getting into means and medians. Thanks for watching.